Asteroid impacts. Scientists may predict when a huge meteorite will crash into our Earth. A team of scientists from universities in Australia and the United States are studying the Wolf Creek crater. It's one of the largest meteorite crashes in Australia. It's said to be the second largest on Earth. I don't think so. We recently found that the Younger Dryas had comet impacts that affected the whole Earth, and one of them was supposedly what hit the Hudson Bay and created Hudson Bay in Canada. But that's above the Great Lakes. But anyway, going back to this, there are, from what I recently read, 50 confirmed asteroid impact sites on the continent of Australia. Now, new analysis enables scientists to forecast how frequently huge meteorite strikes the Earth. How can they do that? Now, the researchers took a look at several features of the Wolf Creek crater. It appeared after a 14-ton meteorite, reportedly traveling at a speed of 17 kilometers per second, crashed into Earth thousands of years ago. It was thought that it occurred, geologically recently, 300,000 years ago. But it has turned out that it happened more recently than 300,000 years ago. A team of scientists conducted 2 tests verifying the age of the crater. The exposure dating looked at how long the soil in the crater was exposed to cosmic radiation, while optically simulated luminescent measured how long ago mineral grains were last exposed to sunlight. That's astonishing, isn't it? Now, after having assessed the results, the researchers found that the crater is only about 137,000 years old, although the meteor impact most likely occurred about 120,000 years ago. So that's geologically pretty recent. Astonishing. So what's so special about the fact that a crater in Australia has turned out to be much younger than previously thought? You may be asking yourselves. There is lots of space debris always hitting our Earth. We know that recently we found astonishing things coming out with the new technology that's available to the scientists. We have over 25,000 comets coming at us from the North Pole and South Pole. 25,000 comets bringing with them 20 to 40 tons of water. And they don't smack us at our atmosphere. They strike us at our position of the Earth's magnetic field. 25,000 of those, 20 to 40 tons of water every day. Besides that, we're hit with, I don't know how many tons, I think 40,000 tons of space dust from asteroids that come hitting us at our atmosphere daily. Of course, these are the ones that are so tiny that we can't see them. But they do hit us, and they do come in. And they bring cosmic soil to us. That's astonishing. So we get debris coming at us, the very dusty, very small particles that we can't see, plus water. 25,000 strikes a day from the poles, 20 to 40 tons of clean water every day. Amazing. So the debris, the space debris, is constantly hitting our Earth. Most of it burns up in our planet's atmosphere, and only huge bodies, asteroids, meteors, even comets, manage to survive the journey hitting our planet. So determining the age of these craters enables the scientists to calculate how often these types of impacts take place. They have 7 sets of impact craters in Australia, and it includes this one, the Wolf Creek crater that they're studying, that dated back to 120,000 years ago from what they said. This is what Tim Burrows said. He's a professor at the University of Wollongong, and he led the research. He says, although the rate is only one large meteor hitting Australia every 17,000 years, it isn't that simple. The craters are only found in the arid parts of Australia. Elsewhere, craters are destroyed by geomorphic activity like river migration or slope processes in the mountains. Since Australia has an excellent preservation record with dated craters within the arid zone, we can extrapolate the rate for the whole Earth. Taking into account that arid Australia is only about 1% of the Earth's surface, the rate increases to 1 every 180 years or so. This is what Professor Barra said. Previous studies suggest that impacts the size of Wolf Crater should occur every, this is astonishing, every 13,000 years. Okay, isn't that something? That 13,000 years number, does that remind you of anything? It reminds us of the Younger Dryas, which was about 12,800 years ago, that brought the new ice age, the Younger Dryas asteroid impact. Yes, I'll leave links below for you for this on Sputnik News. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.